This is demonstration 1.1 on significant figures. To a lot of students, significant figures are simply something they encounter in a problem that can be difficult for them to determine how many significant figures their answer should have. Of course, significant figures are related to measurements, how precisely the equipment is that you are making the measurements. And we're going to do a little demonstration here using volumes instead of lengths, because volumes are what you would generally as a student encounter in the laboratory rather than lengths. I have 3 volume measuring devices right here. Closest to me is a 50 milliliter beaker. It has 10 milliliter graduations. You can estimate volumes to 1/10 of what the volume graduation is. Since the volume graduation is 10 milliliters, we can estimate the volume to about 1 milliliter. So I'm going to make that reading here. I'm going to put this beaker here and face the graduations toward me. I have a little card here with a black piece of tape on it, which will provide color contrast for me to read the meniscus. And a 50 milliliter beaker doesn't have much meniscus, but I'll read it here. And it looks like to me I can read it as 16 milliliters. Not 16.0, but 16 milliliters. The best I can do is measuring it to within a milliliter. And of course it's got units, so I wrote those units down. Now the next thing I have is I have some water in a 50 milliliter graduated cylinder. 50 milliliter graduated cylinders are graduated to 1 milliliter. So 1/10 of a milliliter is the best that I can measure the precision. So that's what I'm going to do here. And if I make this reading, it looks like it's 13.3 milliliters. And I'll write that down. And again, it's a physical measurement, and I'll write units down here. Now, our next volume measuring device is a 10 milliliter graduated cylinder. A 10 milliliter graduated cylinder has graduation marks of 1/10 of a milliliter. So I can do an estimation to 1/100th of a milliliter. Now on a graduated cylinder, that's quite difficult to do because the graduation marks are really close together. So there's quite a bit of uncertainty in that last digit. Just like they were, there's considerable uncertainty in the last digits of these. If I read this is more difficult to read, I get 4.88 milliliters. Now, if I add those numbers together, I get 34.18 milliliters. That's the sum using these numbers of my volume. But if I'm going to add those volumes together, what I'm going to do is I'm going to pour all of the volumes into the 50 milliliter beaker. It should make sense to you at this point that no matter what the precision was that we were able to read the 10 milliliter graduated cylinder and the 50, all of that's going to get washed out by the lack of precision in the 50 ml beaker. So I'm going to pour this in, and I'm going to pour this in, and let's see the volume that I can read off of here. And I'm reading about 34 milliliters. That's my actual reading on there. That's the very best I can do. The best I can do, this is really 34 milliliters, could be 33, could be 35. So you see the importance of significant figures. It's just not numbers in a problem. You're limited by the precision at which you can make the measurements. Here, when we add things together, it's determined by the least precise measuring device. And when you do multiplication and division, it's a little bit different. It's limited by the least number of significant figures in the measuring device because all of the measurements you're making are different.